Okay, so now we're looking at worksheet 12G, the odd numbers. This is the third video of the set of videos. Okay, so the question says, okay, we read through the question already and we already marked that B2 was X. Okay, the question says prove that B1 is equal to B2. Okay, so firstly we can say that, so that's 90. So we're going to prove congruency here. So we say in triangle ABF and triangle TBF. Okay, what can we say at this point? Firstly, we can say that BF is a common side. As you can see, BF is in both triangles, okay? Then F1 is equal to angle F2, which is equal to 90. Okay, because it is given that AD was perpendicular to BE. Okay, so 90 and 90. And we see that those two lengths are equal, so AF is equal to FD. Why? Because it's perpendicular from center to chord. Perpendicular from center to chord bisects the chord. So therefore, triangle ABF is congruent to triangle TBF. Why? Side angle side. Okay. So since that is the case, we now can say that angle B1 is equal to B2, which is equal to X. Why? Because we have proven that triangle ABF is congruent to triangle TBF. So because the two triangles are congruent, all the corresponding angles and all the corresponding sides are equal. Okay. So let's go with number 2. 5.2. Let's use the same color. In the last one we're going to use green. In 5.2 the question says, let's prove that ACD, so ACD is 2x. But we already marked that to be x. So yes, ACD is 2x. Why? Because angle in the same segment. Can you see it's coming from arc AD, subtending angle C. It's also subtending angle B. Okay, so angle in same segment. It's coming from arc AD. Again, you don't have to name the arc. Okay, let's look at 5.3. Question 5.3. Let's prove that ACDO A. Okay, this is not 2x, no? ACDO is a cyclic chord. Okay, so we can join that line there. So ACDO. So we can prove that the exterior angle is equal to the interior opposite angle of the cyclic chord. So we can prove this is, yes it is. Can you see this angle here? This angle at center is twice angle at circumference. So this angle AOE is 2x. Okay? But this angle here is also equal to, but it has to be equal to the extended angle. Okay, so to prove cyclic chord, you're going to prove one of three things. Okay, we prove the exterior angle is equal to the interior opposite. I just realized that it has to be extended there, so it can't be that one. Also, we can prove that opposite angles of cyclic chord is supplementary, and we prove the bow tie. Okay, one of those three. Okay, my mistake was I marked the wrong chord. So it's GCDO. It's this chord here. I marked the. That was my mistake. Okay, so as you can see, this is an exterior angle. Can you see that? So if I can prove that this is equal to the interior opposite, if I can prove this is 2x, I've done the job. However, if we look here, this angle at center is twice angle at circumference. So O2 is equal to 2x. angle at center. Okay, we didn't see that. It's O2 is this angle here. It's coming from it's subtended by chord DB, and DB is also subtending B2. Can you see that? So if that is x, this has to be 2x. Angular center is twice angular circumference. Now we can say since O2 is equal to angle C, which is equal to 2x, therefore it's the cyclic quad. Why? Because the exterior angle is equal to the interior opposite. Okay. Okay, so my mistake was I marked the wrong quad. So O2 is so since O2 is equal to angle C, which is equal to 2x, therefore GCDO is a cyclic quad. Why? Because the exterior angle equals the interior opposite angle. Exterior angle is equal to the interior opposite angle. Okay. Okay, if I made a mistake or anything, please let me know on that number. Otherwise, these videos are free. There's also an easier way to explain something, or I've explained the concept incorrectly. Please let me know on that number. Okay, otherwise the videos are free. Okay, now we're looking at number 7. Number 7, we are told that all the lines are straight. Okay, so it's going from there. So A, C, G, F is a straight line, and so on and so on. You must prove that B, D, E, A is a cyclic quad. Let's just mark this properly. So it's B, D, E, A. Okay, so to prove that something is cyclic or quadrilaterally cyclic, we prove that the opposite angles are equal. No, opposite angles are supplementary. The exterior angle is equal to the interior opposite, as well as, okay, I see it already, as well as the converse of the angles in the same segment. So if you look here, if I can prove that E1 is equal to this angle here, I've done the job. But E1 is equal to angle G. Why? Angles in the same segment here, as you can see that. And then G3 is equal to that interior angle. Okay, so this was actually easy. So let's start off by saying let E1 equal X. You don't have to, so it's a simple question. So then G3 is equal to X. Why? Angles in the same segment, and it's coming from arc AF. Okay, it's coming from arc AF. Okay, so there's your X. So G3 is equal to ABD. So ABD is also equal to X, exterior angle of cyclic quad. Exterior angle of cyclic quad is equal to the interior opposite angle. Okay, so that's also X. So now you see that we needed to prove that's a cyclic quad. So since angle E1, we're stating the obvious, is equal to angle ABD, which is equal to X. Since we have proven that, therefore BDEA is a cyclic quad. Why is it the cyclic quad? Because the exterior angle equals the interior opposite angle. Okay.